Welcome back, students. In this section, we'll try to understand all the concept of ANOVA or F distribution. F distribution is widely known as ANOVA, analysis of variance. AN for analysis, O for off, and VA for variance. Now, this is a very important tool for researcher to understand that how the population mean and the group mean and uh, you know mean between the groups within the groups are distributed. Now through this ANOVA, we do this ANOVA or F distribution to understand the important questions, to understand or answer the important questions generally which researchers try to find out. What are those questions? What is the probability that two samples come from the same population that have the same variance? Or it can be that what is the probability that three or more samples come from the same population? Both the cases, the questions are very, very important for any researcher or any data analyst, statisticians to understand. Now, previously we could, analyze with one or two variables. We have seen x1, x2, and so on and so forth. But herein we can do more than three variables taken together. Now let's take an example on this diametrically. Okay, in that case, as I am telling you that this is a, let's say, total population. Okay, and there are three internal population mean or sample mean I'm talking about. So let's say this is A, this is B group, and this is C group. Three groups are there. Okay, and this is the total population represented like this, right? And I'm representing this as a mu A, this is mu B, and this is mu C. Okay, that means the mean for group A is mu A, mean for group B is mu B, and mean for group C is mu C. Now in this case, if we create the null hypothesis, it will be mu A equals to mu B equals to mu C. Either all are equal, or as per alternate hypothesis, it will be not equal. These are two hypotheses generally we make for the analysis of variance. But the question is very simple. What is this and all? Okay, what is this A, B, C and all? There are two concepts we need to remember. One is between the groups and the within the groups. Between the groups means how far group mean stay from the total mean. And within the group means how far individual values stay from their respective group mean. Now, we need to remember that ANOVA is a parametric test. It's a multivariate technique when we need to understand the difference of mean variation. So, whenever we are talking about the ANOVA F distribution, we are dealing with the mean of different groups, right? So, now you can ask me a question that how come it is possible, Sumit, that it is a mu A, mu B, mu C, and it cannot be in a different way? Why not that we could test the each pair like this, mu A equals to mu B, then I will again check mu B equals to mu C, and again I will check mu C equals to mu A. So I will be taking two means together, and I will try to compare them, and then hence I will say very simple: A equals to B, B equals to C, C equals to A. That means A equals to B equals to C. That means mu A equals to mu B equals to mu C. Hence null hypothesis is proved. Correct? Wrong. What happens in that case? Understand the confidence level instead of 95%. Consider we are talking about alpha is 0.05. Correct? All the cases we are considering it may be 0.01, it may be 0.1. It is applicable for everything. Correct? So now consider that confidence level what we are considering 95%. So in that case, if I consider try to prove the null hypothesis, like if mu A equals to mu B, mu B equals to mu C equals to mu A, then the confidence level goes down from 95% to close to 85%. How? Let's say this is alpha equals to 0.05. In this case also alpha equals to 0.5, sorry, 0.05, and in this case also alpha equals to 0.05. Clear? But the problem is overall the confidence level drops to 0.05 multiplied by 0.05 multiplied by 0.05. Why? Because I am saying the confidence level of A equals to B equals to C is which we are trying to say in this manner, which is wrong actually. It's a question that why it could not happen. That mu a equals to mu b and mu b equals to mu c and mu c equals to mu a, and hence mu a equals to mu b equals to mu c. Correct? Now in that case, as I'm saying and, that means that is the reason multiplication of all this confidence level. So that means if I multiply this, we'll get 0.857, which is nothing but 85.7%, which is not good, which is not good. Correct? Hence, ANOVA comes into the picture and F value, or we call it F distribution, is introduced. Hope you have understood clearly what is the concept of ANOVA, why we consider the null hypothesis like this, alternate hypothesis like this, and not like this. Clear? And what is the mu A, mu B, mu C, what are the groups A, B, C, and what is the population, and so on and so forth, right? So in this manner, through this approach, we can understand, you know, the concept of ANOVA, and we can deal with different groupings. Hope you have understood. See you in the next section.